Hello everyone, welcome back to VMAC1114 College Trigonometry. In this video we continue with section 5.2 inverse function. So in section 5.1 we already talked about inverse tangent, inverse sine and cosine. In this video we continue with inverse cotangent, inverse cosecant and secant. Okay, so let's get started. So I'm going to put here section 5.2 inverse cotangent cosecant and secant. Alright, so on the first part, let's talk about inverse cotangent. Okay. Alright. So we know that cotangent is 1 over tangent, and last time when we mentioned inverse tangent, we look at the tangent function from negative pi over 2 to pi over 2, so which is from one period. Likewise, for inverse cotangent, we had to look at the cotangent function, and we had to look at one period of cotangent, which is from 0 to pi. So we're gonna start again. We're gonna start with cotangent. So we know that y equal to fx, cotangent of x, and we swap it. Okay, and we get a y. So it's going to be inverse cotangent of x, or is we can call arc cotangent of x. Okay, so this is the notation for inverse cotangent, and as I say, we have to start from the cotangent function. So let's start from the cotangent function. Okay, so we're gonna have a cotangent function look like this for one period. Okay, that's y here, it's x here. So one of it is one period from 0 to pi. So this is asymptote right over here. And this is what this is pi over 2. Pi over 2 here. And this is what the cotangent look like for one period. Alright, so this is cotangent. Okay. Now you see that if we look at the one period, you see to satisfy the horizontal line test. So on one period only, the cotangent function has inverse. So what the inverse look like? So this will be the graph of the inverse of cotangent. So we just do a reflection about the line y equal x. So we're gonna have kind of something like this. So this is pi over here. So there could be the horizontal asymptote, vertical asymptote become horizontal asymptote. So this y over here, over here, and half of them will be here. So it's gonna go like this. We're gonna make it a reflection. So it's kind of about like that. So it's gonna be like this. There you go. So right now there's negative 1 over here. Alright, so there's the inverse cotangent. Okay. Now again we look at the domain of this one. So domain domain of this one will be from 0 to pi. Not included because you see it at the vertical asymptote, and the range will be go from negative infinity to positive infinity. For the inverse, then the domain here, you go from negative infinity to positive infinity, and the range is go from 0 to pi. So this is pi right over here. This is y equal pi right here. Okay. And they also have the relation between the cotangent and between inverse cotangent and inverse tangent. So I'm going to put here identity. We know that inverse cotangent will be equal to inverse tangent of 1 over x, or it could be equal to pi plus inverse tangent of 1 over x, and this is for x greater than 0, and this is for x less than 0. Okay. Okay. Because in this video I won't be doing too many example. I'm gonna do example at the end because it's kind of similar to example last time in section 5.1. So I'm gonna do all the theory first for each function. Then at the end I'm gonna do example. Okay. Now for the second Roman, we will be talking about inverse cosecant. Okay. And again we know that y is we start with the cosecant of x, and we swap them. Okay. Then we're gonna have y equal to inverse cosecant of x. Yeah, okay. We know the cosecant is 1 over sine, so of course, and sine function, when we do inverse, we look at it from negative pi to negative pi. We look at it negative pi over 2 to pi over 2, I believe so. But now we look at it. We also look at it inverse cosecant at from negative pi over 2 to pi over 2. But first I'm going to go ahead graph. Okay. Graph the sine function. Okay. Then we look at the part of the domain which is from negative pi over 2 to pi over 2 overlay. Okay. Now first we graph. Okay. So we're gonna have from negative pi to pi. So we look at it one period, okay, but from negative pi to pi instead from 0 to 2 pi. So this is pi right here. So this is negative pi right here. So 1 right here and negative 1 right here. Okay, so pi over 2 here and negative pi over 2 here. Okay, so the graph of sine will be something like that, right? But we look at it from the other side also, so it's going to be something like this. Alright, it's going to be something like that, and it's going to be something like this, and it's going to be something like that, right? Or I have to sketch it really carefully. Okay, so this is the sine function. Okay, and now we know that for the cosecant it's going to be something like this. It means the asymptote will be over here. All right, the asymptote will be here. Okay, this is asymptote. This is also asymptote. Okay, then this asymptote. Then for the cosecant it's kind of something like that, right? So this pi over 2 here, and negative pi over 2 here. But because when we look at the inverse of sine, we know that we only look at from negative pi over 2 to pi over 2. The same thing over here. For the cosecant, we look at it from negative pi over 2 to pi over 2 only. Okay, so the cosecant will be something like this, right? Like this. Let's see, I can use this color. Maybe, you know what? I'm going to use I try to use pink one, but let me see. This one is better. Yeah, I think that one is good enough. So instead of looking at it from 0 to pi for the cosecant, I'm looking at it from 0 to pi over 2 only. Okay, because just think about it, if you go from 0 to pi for the whole thing for cosecant, and you put a horizontal line test, it's gonna cut at 2 points. It means that it doesn't have inverse, so we have to look at only a part of it. So again, we're gonna look from here to here. Okay, so it's gonna be something like that. Okay. Okay. There you go. Now we look at all the two purple one right here, and you see that of course it's the past the horizontal line test, right? So this is the part of the cosecant we look at. Okay. So this could be the cosecant of x. All right. Now we're gonna try to see if we can get the inverse this one. But first of all, let's talk about the domain first. So the domain over here. The domain over here will go from negative pi over 2 to pi over 2, not including 0, right? Yeah. Not including 0, so we can have negative pi over 2 to 0, union 0 to pi over 2 only. Okay. Then the range will go from negative infinity to negative 1. Negative infinity to negative 1. Union with negative 1 included. Union with 1 to positive infinity. Okay. This color is good. I mean, the color is not really that nice. I think you should have red one, you know, or maybe pink one. But red is not good either, you know. Maybe pink, you know. I can change it to pink a little bit. Maybe this one. What do you think? Or maybe this? Yeah, this one is better, huh? I think we're gonna pick this one. Here you go. So let's change the color a little bit. So I'm gonna change this to let me erase this. It's kind of the same thing. I just want to change the color. I don't like this. It's too dark, you know. So the domain here will go from here. You go. This is good. This kind of pink. Go from negative pi over 2 included to 0. Not included because the horizontal asymptote from 0 to pi over 2. And for the range, you're gonna go from negative infinity to negative 1 included because it's the dot. Union with 1 to positive infinity. Okay. You know what? I think I'm gonna erase this one also. There you go. I'm gonna do ping over there. Alright, let's draw it again. There you go. And over here we're gonna have this. There you go, 2 pieces. Okay. Okay. And it satisfies horizontal line test. So now we're gonna do the inverse. So now range become domain. So the domain now will be negative infinity to negative 1. Union 1 to positive infinity. And the range, now domain become the range, negative pi over 2 to 0, union 0 to pi over 2. Okay. So we're gonna have something like this. Okay, again, we're gonna have okay, and this one gonna be like this. So domain from negative infinity to negative 1. So this is 1 right over here, negative 1 here, this 1 right here. So and the range will negative pi over 2, pi over 2. So this pi must be over here. Pi will be over here, and negative pi will be over here. Okay. And now we're gonna go from this to let me see, we flip it, so we flip it over the y equal x. So this one is gonna be something like that. It's gonna be let's see, let's flip this one over here, this one over this one, you flip it. It's gonna be something kind of like this. So I'm gonna do a different color. I'm trying to use how about we black? Black is not good. You know what? I think we're gonna use black. Okay, so I'm gonna do like this. So the pink part right now become the black part. So it's gonna be something like this. There you go. And over here this is gonna be something. So we flip this one over here. So this one gonna be something like that, right? Like that. Okay, so it's gonna be something like this. Alright, so this is y, this is x. Alright, everybody see that? Okay. So domain of negative infinity to negative, I think I messed up something. It's supposed to be at negative 1. So oh yeah, something not right. So this one is pi, this is pi over 2, guy. Yeah, something not right. This is pi over 2. It's negative pi over 2. So negative 1 must be over here. Yeah, that's why. Oops, that's something not right. Let me fix that. Okay, so let me erase this. This is not good. So negative 1. So domain will be there from negative 1 to negative infinity to negative 1. So negative 1 must be over here, and 1 here. Okay, so if you go ahead and grab it, it's kind of the same thing, but it's gonna go like this. Oops, no, I'm gonna erase this. And so it's very hard to grab. Okay, now we're gonna go over here. I'm sorry, like that. So it's gonna be like that. Okay, and over here it's gonna go like this. There you go. Okay, so that's why I go from negative infinity to negative 1, and from 1 to positive infinity. So and the other one is the negative pi over 2 to 0, and 0 to pi over 2. Included pi over 2. Sorry, this is also wrong here. Okay. I'm sorry, I need to fix this also. This should be included. Alright. And they also have the relation between So I have a relation between inverse cosecant and inverse sine. And I say that inverse cosecant to be inverse sine of 1 over x if x is less than equal -1 or x greater than equal 1. It makes sense because only the part right here, the black part, has the inverse. Okay. Alright, so that is the inverse cosecant. Now on the third part, I'm gonna go to the last one is that go to inverse secant. We know that secant is 1 over cosine. So for the last time we looked at cosine from 0 to pi. Okay, 0 to pi. And the same thing over here. We look at it from 0 to pi, and we can grab a part of the secant. We don't grab everything. Okay. So it will be like. Again, we're gonna start with y equal to secant. Swap it. Okay. Alright, or we can write r secant. Okay. Now let's start with just half of the period of cosine. So we look at from 0 to pi only. Okay. 0 to pi only. So this is going to be pi over 2. And we look at from 1 negative 1. So for the secant, so we're gonna go like that, right? Okay. Okay. And usually we're gonna have something like this for the secant. For the cosine, we look at it like this only. Then for the secant, we're gonna go like that. So I mean the asymptote will be over here. Okay. For the secant, we're gonna look at only this one only, this part right up here. So so we're gonna look at this. So we're gonna have this. Okay, and over here. Okay. Okay. This is x, y. Now you see that the pink part is satisfied or horizontal line test. So the domain over here, you go from -1, from 0. I'm sorry, 0 included. 0 to pi over 2 not included. Union pi over 2 to pi included. Pi over 2 not included because it's asymptote. And the range go from -infinity to -1 included. Union 1 to positive infinity. Okay. And now we're gonna do the inverse. Do the inverse. So we're gonna have something like that. Okay. Now we look at it from 0 to pi. So let's say pi over here. Okay. So the asymptote will be pi over 2. This is pi. This is pi over 2. And now range become domain, so it means that we're gonna have domain right over here, -1 to 1, -1 to 1. So it will be -1 here and 1 here, and domain become range 0 to pi. So -1 to 1. Domain become range. So we're gonna have kind of something 0 to pi. So this start at pi. So we're gonna have right over here. So that's one right here, and this is another one right here. So the first one you're gonna have something like this. Okay, so the domain, you see that domain from 0, domain become range become domain, so this become domain, right? The black one, -infinity to -1, and 1 to positive infinity, so it's gonna be something like this. There you go. Okay, so right now we have domain from -infinity to -1 included, union 1 positive infinity, and the range is go from 0 to pi over 2, or 0 included, I'm sorry, 0 included, union pi over 2, pi over 2 not included, to pi included. There you go. And they also had a relation identity between the inverse secant and inverse secant and inverse cosine. Okay. So we also know that secant, inverse secant of x could be inverse cosine of 1 over x if x less than or equal to -1 or x greater than 1. Alright. Okay. And now we're gonna go ahead and start with some example. Let's see how we're gonna use the graph here to evaluate the inverse secant and inverse cosecant. Okay. Okay, so let's get started with our example. As I said at the beginning, because it's kind of similar to section 5.1, so I won't be doing many examples. I just probably give you one of them. The example that relate to the inverse secant or inverse cosecant. Okay, all right, let's get started. Example here. Okay. Find tangent of inverse secant of -3. So again, it's similar to the same concept in section 5.1. We're gonna let y equal to secant inverse -3. Then from here, I can write a secant of y equal -3, and secant is 1 over cosine y equal to -3, which is cosine of y will be equal to -1/3, will be less than 0. And cosine is negative, so this will be quadrant 2 and 3. Okay, and now the inverse secant. So inverse secant, we know the inverse secant is this. So for the inverse, the range could be from 0 to pi, right? The range could be from 0 to pi. So this is the y could belong to this pi over 2 union pi over 2 to pi. So basically, this is the quadrant 1 and 2. Right. So from these two information, we can conclude that the final quadrant we're looking at quadrant will be quadrant 2. Okay. Now we go ahead and draw the picture. Quadrant 2. Alright, so we're gonna have quadrant 2 here. Cosine will be cosine. This is y over here. Y over here. Alright. Cosine called adjacent over. So this is kind of wrongly, but let's change this. So let's change this. It should be a little bit. That's weird. I cannot erase it. What happened? Oh, that's weird. I cannot erase this for some reason, some way, somehow. Oh, why? I don't know why I cannot write it anymore for some reason. Let me fix that a little bit, okay? Okay. Let me draw that again. So this is a quadrant 2, and cosine is negative, so cosine is adjacent over hypotenuse. So it's going to be something like this. Okay. Okay. So over here will be what? 2 square root of 2, right? Okay. 2 square root of 2. So this is angle y. Okay, so the reference angle will be this one. So we can find tangent. So tangent of y will be tangent of inverse secant of -3. Okay, it will be 2 opposite over adjacent. So tangent in quadrant 2 will be negative. Will be -2 square root of 2. Actually, it would be 2 square root of 2. 2 square root of 2 over -1, right? Tangent is opposite over adjacent. Actually, the answer will be -2 square root of 2. Alright. Okay. There you go. Alright, so that's simple. The other one will be kind of the same thing. So I'm gonna just stop right over here because it's going to be similar. So by the time we go in class, we're gonna do more practice. All right, I'll see you next time. Bye bye.